Hello, this is Vincent Lussenberg and I'm a technical product manager for SaaS Labs' Backtrace product. In this short video, we'll see how to prioritize errors and crashes in your mobile app. You get automatic deduplication of errors across tens of thousands of different devices. We'll see that you get multiple platforms in one overview. We'll explore the rich bidirectional workflow integrations with Jira, Asana, Slack, Discord, etc. We'll look at multiple metrics that will aid your prioritization. First of all, the automatic best-in-class deduplication, percentage and amount of affected versus problem-free users and sessions, grouping by device, version, platform, and many more attributes, flame graph to inspect particularly problematic code, the ability to zoom in to individual sessions, and finally, aggregation of millions of reports with minimal lag. Let's now take a look at an environment where we've gotten a large number of such errors, hangs, and crashes. How would we triage or prioritize what we need to work on? We're here on the default overview screen. What we see here gives a high-level overview of the health of our app and the trends. We do not only see the raw amount of errors, we also see how many users and app launches are essentially error-free, meaning an error was never reported for that user or app session, indicating healthy behavior. We can see the errors sent by app version or in total. We can also see the trends of which app launches didn't encounter errors or crashes, which is essential context for issue prioritization. The release view is dedicated to give ever more insight into problems that might have happened in one version but not in another. In this case, we can clearly see there's a problem with version 2.10, that 25% of my user base is still on. We see that only 60% of the users there is error-free, meaning they have healthy sessions without problems, versus 90+% for the other versions. Let's take a look at the triage overview. The triage view shows what active issues we have in the app and what the statuses are, where we can also see links with Jira tickets. Let's take a look at one of the auto-created issues. We see that the Jira issue is populated with all kinds of information, and the status is bidirectionally synchronized with Backtrace. This allows us to know if an issue is already worked on in real time or solved. Note that I did this demo with Jira, but many other issue trackers such as Asana are also supported. How does Backtrace know how to create a group with errors and to create a ticket for the group instead of for each individual error received? This is because of our best-in-class deduplication. Our advanced algorithms create buckets for problems that we detect have the same root cause, identified by the attribute we call fingerprint. Of course, this greatly aids making decisions on priority because it allows us to see what the biggest group of problems is. We see the error-free metrics on the triage views too. So for a group of errors that share the same root cause, we see the absolute number of errors, but as well as how many of our sessions and users are affected by this. Backtrace can also reopen a ticket automatically if it is believed to be fixed in a certain version, but Backtrace detects the same problem again in a later version. It will reopen in Backtrace and the linked Jira or Asana as well. Backtrace's custom database is made to be very flexible in slicing and dicing your data. Let's group our errors by version and try to find out more about the high failure rate in 2.10. We see that Backtrace is able to see the number of launches per application version and therefore can show us that the error rate is much higher for version 2.10, 13% instead of around 3% for the other versions. Let's see if the error rate is higher for iOS or Android. We can select sysname, a standard attribute that the SDKs capture, and show a distribution. We see that there's no discernible difference. Let's try process age, the amount of time the app was up when the error was captured. We select a bin view. This operation is available to us based on the data type of process age, a positive number. We clearly see for the problematic version, the app dies very early on in the process compared to the other versions. Release channel is a custom attribute that this app added to the reports, which indicates where the app is in the release process. Refer to the SDK instructions to see how to add custom attributes to your reports. Again, when we show a distribution, we see no discernible difference between the versions. It's not related to the app being in test or production. We can also select hostname. When we create a distribution for that, we do see a difference. It looks like for the healthy versions, no device has a significant amount of errors more than the other ones. For the problematic version, 2.10, we however see clearly that there's 10 devices that generate almost all of the problems in this version. Also notice that the host name is obfuscated to prevent PII data from leaking. You can see how slicing and dicing by these different attributes makes my prioritization very data-driven. Not only do I now know that overall my app is very healthy and only the 2.10 users need to be upgraded, I also found out that only 10 devices are really affected, reducing the anxiety that I might have over this problem. Note that this is very hard to impossible to do with a more simple error management platform. Let's now try to look at an individual session. Backtrace allows you to look at things in a coarse-grained and a fine-grained way. If I want to follow an individual session or user, I just filter to that and switch to list view. Now we see everything that happened during that individual session. We see a number of hangs preceded the crashes. That is important information we can use in our next step, debugging the actual problem. Let's clear the filters and look at the flame graph. The flame graph shows the call stack paths across all of my errors. This allows me to see which paths in my code are most brittle or hang prone. Especially for tracking down hangs in third-party libraries such as ad networks, this view can be a lifesaver. We've seen now how to prioritize issues by slicing and dicing through the database of Backtrace. Please join me in the next video, where we will explore how Backtrace will help you debug and resolve the individual problems now that you've decided which to prioritize.